rotation. So I called the last one what? PCA2. So I'm going to call this PCA oblique 1. Still principal. That's what I like about that. It's gives us the option of doing orthogonal and oblique rotations. But the rotate I want to use here is OBLIMIN, I do believe. Yeah. So I got PCA OB1. And everything pretty much looks the same, right? There's only one thing that's additional. These things right here are still your factor loadings. Notice that our commonalities and unique variance didn't change. These things here are still called our eigenvalues. But the thing I like about running the oblique is it gives us the correlations between the two components. Now, if I had correlations between component 1 and component 2 that was less than 0.3, then I would feel comfortable with just reporting what I got from the orthogonal rotation. But you know, again, it's a close call. But with the 0.35, I would feel more comfortable controlling for that and running the oblique rotation, which we just did. Now, the tough part about oblique rotation is the following. Orthogonal rotation is, well, regardless of the rotation, we get into two types of matrix. We get into a pattern matrix and we get into a structure matrix. Now, for orthogonal, these two are the same. For oblique, these two aren't the same. So, guys, it should be pretty commonsensical from here that since we ran the oblique, we need to create the structure matrix. Okay. Now, again, by default, the principal creates what's called your pattern matrix. So we're going to come in and look at our structure matrix and see if there's any difference. This is quite a lot to type, and I have to write it down. So, see, what we call this? PCA OB1. So PCA OB1, and we want to look at our loadings. So it's just multiplying two matrices. Times 5. And phi is just the transition. We think of phi as being the angle between the rotations. All right, just checking my... So guys, our structure matrix looks like this. And I want to compare those. It looks like to me, let's see, 0.89. So the structure matrix has, let's look at things bigger than, so 0.90, 0.90, 0.89. So there's consistency around the 0.9, telling us calculus, trig, and algebra load on component 1, and then structure consistency around the 0.8 mark, telling us stats, logic, and problem solving load on component 2. So, guys, I think that the structure matrix and pattern matrix support what we knew all along from the orthogonal rotation. So guys, again, I'm a happy man. If I were publishing this, I would be extremely, extremely happy. Now, we'll focus on factor scores. And factor scores are extremely helpful for us just in case we want to use these latent variables in future analysis. So guys, I'm going to do final PCA. And so I went principal. So this is going to be the drum roll, please. Data. So we know through all of our hard work that we went 2 factors. We know from the correlation matrix between component 1 and component 2 that we have reason to believe that we need a oblique rotation. But now we want to include our factor scores. And you type final PCA and you're like, wait a minute, what did Darbo do to us? There's nothing different. Well, just because you created the scores doesn't mean you yet see them. So I'll have to go final PCA, $ scores. And we get our component scores for each of the students. Okay. Now, essentially, these scores just tell us how these how they score on each component, really, and so it compares subject 1 on symbolic manipulation to subject 1, same subject on liberal arts. Now, the beauty of factor scores is you can use these in future analysis. So let me give you something that a couple of scenarios. Let's say, for example, that we had all these scores, and we wanted to, but we also had some ACT scores. So, guys, I'm just going to create some ACT scores here randomly. So to go along with this, so I'm going to go R norm, and I'm going to create 73 of them. From a mean of 21, standard deviation 5. And I want this to be rounded to 0. So guys, when I get my ACT scores, you can see I've got 73 ACT scores that I just created randomly. So don't put a lot of stock in this because those were just created randomly. Okay? Now, what I could do is I could create new data 1 and create, I'll tell you what, let me get the names of data. Okay, so I could create new data number 1 where I'd create a data frame with calculus, trig, problem solving, logic, stats, algebra, and ACT. And you can see I have a new data set. Okay? What I could now do, if I wanted to, is I could try to predict ACT using a linear model. So ACT predicted from, no, we'll get these. Okay, so I want to predict ACT. I'm sorry. So I want to predict ACT from calculus plus trig plus problem solving, plus logic, plus stats, plus algebra, and I get no statistical significance. Got standard errors that are relatively high. Guys, I got major multicollinearity going on, because if I go back up to my original matrix from many moons ago, I see that I have some variables that are highly correlated. Let's see, what do I actually get into that was highly correlated? Looks like trig and calculus are pretty highly correlated. Really, after I look at this, it's not as much multicollinearity problems as I thought. We could run some variance inflation factors and tell for sure. Another way to do this is to get, let's see, what did we call the scores? TC1 and TC2. Okay, I've got to some way go in here and save these scores. Final PCA scores. Okay, let me. All right, let's save these as. All right, so let's go new data. I'm not even sure this is going to work. Yeah, okay. Now, what I could do is I could run a model. As I'm losing it here, this has been on new data too. And you can see that it's saved TC1, which would be symbolic manipulation. And TC2 would be liberal arts, and I could predict ACT from that. Okay, what am I going on here? Okay. All right, this should do it. If not, I'll have to get back with you on this one. Yeah. So I go summary, model 2, and you can see that, well, neither one of them turned out to be statistically significant, but you think about it, I randomly created those ACT scores, so you wouldn't think that there would be much relationship. So guys, in times of that we're wanting to identify latent variables, these underlying constructs, such as symbolic manipulation or liberal arts skills, or depression, or bullying, or whatever it may be, these things that aren't necessarily observable in terms of data that we can collect, then this process is very, very, very helpful. It's also going to be extremely helpful when we get into test theory. Well, guys, that is it. I am tired. I'm ready for this to be over. So that's it. Take care.